Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello and welcome to this week's episode of Better Buildings for Humans. I'm your host, Joe Menchefski, and this is the podcast where we look at the impact that the built environment has on our health, our wellness, our productivity, our general joy of being alive. And of course, we have to look at sustainable design as well. Today, I have an amazing guest. I have Marilyne Andersen from EPFL in Switzerland. I'm going to read, I don't do this very often, but today I'm doing it. I'm going to read a little bit from Marilyne's LinkedIn page. Okay. We'll come back to Marilyne, I swear, but we just have to read a little bit about this. Okay. Brace yourself. Marilyne Andersen is a full professor of sustainable construction technologies and heads the Laboratory of Integrated Performance in Design that she launched in the fall of 10. Since April 15th, 2025, she is Director General at GESDA, Geneva Science and Diplomacy Anticipator, which she's going to talk about in just a minute because it's really cool. I'm not done. She was Dean of the School of Architecture, Civil and Environmental Engineering at EPFL from 2013 to 2018 and is the Academic Director of the Smart Living Lab in Fribourg. Fribourg or Freiburg? Fribourg. Okay. She also co-leads the Student Creativity and Innovation Laboratory at ENAC before joining EPFL as a faculty. She was an assistant professor, then associate professor tenure track at the Building Technology Group of the MIT School of Architecture and Planning and head of the MIT Daylighting Lab that she founded in 2004. She has also been invited professor at the Singapore University of Technology and Design in 2018. Marilyne Andersen owns a Master of Science in Physics and specialized in daylighting through her PhD in Building Physics at EPFL in the Solar Energy and Building Physics Lab, and is a visiting scholar in the Building Technologies Department of the Lawrence Berkeley National Laboratory in California. Holy cow! Welcome to the show, Marilyne. It is an absolute honor to have you here.
Thank you. Very nice to be here, Joe.
Let's talk right away. I covered a little bit of your resume, but it's also nice for our listeners to hear the story from you. Tell us a little bit about yourself, about the path that led you to become a professor of sustainable construction technologies at EPFL and all the related work that you do.
Thank you. Yes. So, I think this resume was a mouthful and made me realize I should probably update the page to make it a little simpler and more digestible. But in a nutshell, I'm a physicist by training. And at the time, I had a lot of hesitation with architecture because I love the world of drawing and art as well. But it was a good decision to be a physicist. But then I went back to kind of my initial love also for buildings, did my PhD in the building sector on facades, did part of this PhD in Berkeley at the Berkeley Lab, then did my tenure track at MIT. And this is where I shifted from more, let's say, optics related aspects of buildings, facades and technological to human aspects of lighting. So the effects of light on humans and the psychophysiological effects in particular, especially in connection with the Harvard Medical School that was a neighbor. Then when I came back to EPFL as a professor, indeed, a couple of years later, I became dean of a school, the ENAC school, that is actually deeply multidisciplinary and that I hadn't studied in. It's in architecture, civil engineering, and environmental sciences, and where I launched a few projects on project-based learning, like I brought the school with other schools to participate in the Solar Decathlon competition on solar housing in the US. Also launched a sort of hands-on project-based learning makerspace called The Skill, a new research center that you mentioned in Fribourg that is now, whose academic director now is someone else after 10 years of carrying this torch, also some innovation programs. Anyway, and so indeed now I'm leading also a project on the energy transition at the Swiss scale. And I really enjoy this connection with art. So back to the very beginning, I have been co-curating an exhibition called Lighten Up on chronobiology and the effect of light on humans, and therefore allowing the art to become a vehicle to transmit, disseminate knowledge about scientific themes and get the public to be more aware of, in this case, how important light is to us through more of an emotional, very personal lens.
Do you want to bring lots of healthy, beautiful, natural light in your building and still meet energy codes? Try Solera from Advanced Glazings. Learn more at advancedglazings.com. That's amazing. We're going to come back to several of those things that you mentioned on your journey there, Marilyne. First, I want to talk about the Daylight Academy, who introduced us in the first place. Some people from the Daylight Academy who do amazing things as a daylighting practitioner. I follow them very closely. Tell us why the organization exists, what it's trying to achieve, and how it goes about achieving those goals, Marilyne.
So this academy is there to create a community around daylight, but in its many different dimensions. So it was maybe first related to daylight in relation to, let's say, our living environment, but it's expanding to health, sort of environmental aspects, so really nature in its broadest sense, to art through communication. So it's a very broad community of people that have a place in their heart for daylight and do that in their professional lives. My own role has been as founding member, because I have been working on daylight for basically all my professional life. And therefore, I'm an active voice in this academy. I, in fact, declined to take a formal role. There was a question to be chairing the steering committee, but I am doing some other things and I prefer to stay involved in these other activities that I have. But I was more recently part of a working group on societal topics, kind of a strategic advisory group, so to speak, to think about what the DLA could, the Daylight Academy could become in the near and sort of midterm future.
Right. Okay. Let's talk about the Daylight Award. I learned about the Daylight Academy originally, I think, through a Daylighting Award that several years ago was won by Dr. Russell Foster from Oxford. And it was really interesting. He did some great work on using daylight as entrainment for writing our 24-hour clock. It was an extraordinary conversation. But let's back to the award. Can you tell us a little bit about the award, the categories, the criteria for the awards? Share some of that with us, Marilyne.
Sure. So actually, the Daylight Award has taken a new shape since 2016, where it became a dual award, one award for research and one award for design. Before that, still existed, but it was a bit more specific and mostly about built projects. So it was a bit more narrow in scope, let's say, and it was also more on a national level, either Denmark or Switzerland. So it became global. And I happened to have been the inaugural laureate of that award when it became global.
I didn't know that.
For me, it was as the research awardee, and then it was alongside Stephen Hall for design. So that was in 2016. So it was the first edition of this new way of thinking about the Daylight Award. And it was wonderful. We had a ceremony in 2016, and then we had lectures that we both gave the following year in both Denmark and Switzerland. So since 2016, I've been on the jury. I've been on the jury, let's say, in 19, 20, and 22. So it's an award that is given every 2 years. And then there was another edition in 2024 where I wasn't on the jury anymore because they want to renew the jury. So I guess by having been both a laureate and a jury member, I kind of know how it works. So how it works is, and I didn't know that before being the laureate, but it is through nominations by others. So you don't self-nominate, you don't apply. But if people elsewhere nominate you, you are part of a pool that is then considered by the jury that they can expand on if they want to. It's sort of open, but it's still the sort of the starting pool. And so the topics are also covering quite a range, but there too, I would say that, so both Stephen Hall and myself are in the built environment for sure. So I guess it expanded from more building science to also include health. And this is when Russell Foster became an awardee, and also Anna Justice and actually Till Runneberg, actually all three in chronobiology. So you can see that chronobiology is very present, but the idea is to expand it even further, although finding a relevant perimeter remains difficult because daylight is basically life. So it's kind of everything. And so this is a strategic thinking that the DLA now has to do, is to how to define the scope and the perimeter.
Fantastic. So Marilyne, you mentioned the word chronobiology several times, and we've talked about chronobiology multiple times on the show, but just in case we have any new listeners who aren't familiar with the term, can you sort of at a very high level define chronobiology for us?
Sure. So very simply, chrono is for time and biology is for life. So it is the connection, relationship between time and life. And more specifically, it, at least in the way that it was dealt with in the DLA with these awards, and also the work that I'm conducting, which is also related to chronobiology, is about the impact that light has on us and on all the living species on Earth by being a giver of time to the living. And so this can sometimes also be called photobiology, but chronobiology is really time and biology. So this is basically it's through the lens of light. It is our deep connection that we have with light as a giver of time, and therefore as a very important health component or physiological component in our life.
Perfect. Okay. Let's talk about you. There's a couple of questions outside of the Daylight Academy and talk about your research and your work. So, as head of Laboratory Integrated Performance and Design, LIPID, at EPFL, you've been at the forefront of integrating daylight into sustainable building practices for some time, as we've heard. What are some of the most significant innovations or tools that your lab has developed that enhance daylight utilization in architecture, allow us to do it more often, to do it more effectively?
Yes, so I would say it is in three types of domains or directions. And I'm talking here about my work at EPFL at MIT. As I told you, it was going from more technological aspects into more human, but now I would say a little more fully human. So on the one hand, it's about physiology, like in relation to chronobiology, actually, as I mentioned before. The sort of big advances we may have contributed to was on the one hand by bringing forward a new mathematical or computational model that was able to bring all the lab findings, the findings from chronobiologists and neuroscientists in lab, and try to make them, turn them into a model that could be a way to predict is maybe a strong word, but anticipate what kind of responses we might expect based on the knowledge so far. So that was one big step. And that became part of a startup that I co-founded with two of my PhD students, one of which actually developed that work to bring that to practice. But we might get to that in a little while. And another thing that we did was that we realized how much work was done in the lab and how much work was needed to translate that to real life. So what we find in extreme conditions in lab, why does that even matter in real life where the conditions of lighting are more subtle? And so for that, the first step is to know what we are exposed to in real life. And therefore we developed a new technology, a spectrally resolved wearable sensor called SpecTrace, that we decided ultimately not to commercialize, but rather to keep it as a prototype in research. But it allows to be a very sort of wearable, not too conspicuous, pretty nicely designed actually, a sensor to be able to follow people's light hygiene in their life. So that is one aspect, more physiological. The second is more on discoveries related to comfort, visual comfort in particular, but also in relation to others. For example, we worked with one of our PhDs, who's now a professor at Northwestern University. She developed experiments to find out whether the color of light that you see or the amount of light that you see, whether this influences your thermal perception of space, even though the temperature doesn't change. Does it actually influence how warm or cold you feel? And actually, the answer was yes, it does influence it, although only a tiny bit. Also, more recent work was on eye morphology. Is there anything in the eye, like macular pigmentation, for example, that influences our sensitivity to glare? It looks like yes, to the extent that we knew it, but maybe not beyond what we knew. But also more generally, what the influence of color, like heavily colored glazing on sensitivity to glare. So this is the kind of things we are also working on and have found interesting kind of new discoveries in. And then on the perceptual aspects, which is the third chapter, it's really to bring up the question that it's not just about having enough light and avoiding contrast for glare, but it's also about embracing contrast and light patterns and sunlight patterns in particular, which are very contrasted but very beautiful, and also views out as very important elements of well-being indoors. And therefore, to work more on what the composition of light might trigger as sort of subjective responses in us. Is there a consensus about that? These kind of things. So these are, I would say, the types of work that we do.
What did you learn? I'm super curious. What did you learn about color? How much did color impact our perception of glare, and in what way?
So we expected that thanks to macular pigmentation, which is absorbing the blue, that we would be better protected from blue light, let's say. So this is true. This was known. What we were wondering was whether this could also have an impact on polychromatic light that would have all the colors, including blue. But the effect was lower than we thought. On the other hand, we looked, or that was another PhD who is now going to be a professor in Canada, University of Calgary. She looked at sunlight through colored glazing and found that we seem to be experiencing more glare when the color of the glazing is red or blue versus when it is green or neutral. So this triggered a lot of questions, like, do we look at these colors more? Why? And we don't know the answer yet, but an answer might be simply that the photometric system as a system is possibly wrong. And therefore, that would be a big discovery, but it's still work in progress.
That's really interesting. Yeah, I'm surprised to hear blue, but it is what it is if that's what the research is showing. And red, they're a good distance apart on, on the spectrum. And yet
they're a
those are
good distance apart, but they are both colors that we are much less sensitive to than green. Green is the color we are most sensitive to, so we need little light to see it. We need much more light to see blue or red. So they have something in common.
Oh, I see. That makes a lot of sense. All right. Let's talk about something else you worked on. You co-founded a company called Oculate Dynamics, which is a startup, correct me if I'm wrong, but it's a startup focusing on daylight performance and its effect on building occupants. How does this venture bridge the gap between academic research and practical applications? How are you taking that research through Oculate and helping with the creation of buildings?
Yeah, it's actually a very literal translation in this case, because this was co-founded with two of my former PhD students, one of which is my professor at the University of Oregon, another is data scientist and working for the government in Reykjavik. Now, so each of them in their PhD that they did at Lipid worked on new models, new ways of calculating or using light inputs to predict something. One was on the health effects or let's say the circadian aspects that we mentioned before, chronobiology aspects. The other was more on contrast, valuing contrast as something nice. And so bringing those two models plus models that we had, and in particular were developed by a senior scientist at Lipid on glare, we had the three kind of key ingredients of how daylight can matter to us as occupants through well-being. So this is really all about psychophysiological effects of light. So we decided to launch this startup. These are all models that are available publicly, but we have the knowledge of what they mean. And therefore, this is a consulting startup that has kind of a specialized take to help new projects or renovation projects to embed the daylight dimension as a key feature and to really care that we go beyond norms and standards, and that we try to incorporate also the newest findings about how light can contribute to create an atmosphere that would be more prone to socializing or working or whatever we want to do, or where they could be some kind of a place to go to feel energized again by the amount of light you can get exposed to during the day, or making sure that we manage glare, but also light sufficiency. And so this is a great tool to really reach out to practice, because then we influence the real world with real buildings, but through a dialogue that is very different from maybe the conventional dialogue you would expect from a daylighting consultant, which is you need to reach that kind of threshold, that's 300 lux, 500 lux, whatever it is on your work plane. And this looks like a constraint. But we have much more fun discussions about well-being and health and excitement in a place, and where could you get your sort of the dose of light that you really need to feel alert. And so these are kinds of discussions with both architects and building owners that are very exciting to have, because it also speaks to them. It's about what they want to have with light and not what they have to have with light because of norms.
Can we go just a little deep? What kind of strategies are you recommending for avoiding high contrast ratios?
So this is kind of a trade-off to find between glare, which you should avoid, at least you should avoid in certain cases, like in workspaces. You should try to avoid it when you don't have a choice of where to sit, and where you have to make sure that you can control your environment to not suffer from glare. But in other cases, sunlight penetration in particular, and patterns of sunlight that move and give sort of life to a space, should be welcomed. So you cannot just work with one metric. You have to work with both favoring glare protection and favoring contrast, high contrast in a sort of a more of an aesthetic or perceptual sense, not in the sense of comfort, but in the sense of having pleasant spaces. And so this equilibrium, we work on it by deliberately never merging these two dimensions, nor the third dimension, which is about physiology. So light dose, how much light you should be exposed to. Never merge them into an average number, because then you lose all the subtleties, but rather keep them separate, but visualizing them together in an interactive way so that you can really sort of project yourself in your future space and realize how it deals with these different dimensions and make decisions based on the priorities you want for your project. So this allows us to really respect architectural intent, design intent, and priorities given, and give, I think, just the right level of information and nuance to make these decisions being better informed than without these models at hand.
Love it. Okay, that's really interesting. Back to the Daylight Academy for just a minute. And so I'm sorry I'm moving around a lot. There's just a bunch I want to cover today. Tell us about the journey of Light platform, just from a high level, Marilyne. What is the platform? What are its objectives? And how are you hoping that it's going to enhance public engagement and understanding of daylight?
Yes. So daylight is funny. Everybody knows what daylight is, except that maybe many people just think daylight is the sun disk. At least that's how you see it represented in many architectural drawings. This is more than that. Daylight is the sky and the sun. The sky, of course, is illuminated by the sun. But so everybody knows what it is. And yet not many realize how this translates into research questions, into challenges to be solved, into societal questions on public health, on behavior, on modern lifestyles, on all of these questions. So it's both very simple and everybody knows what it is, and it's multidimensional, multifaceted, so not so easy. And it's from the microbe scale to the urban and sort of from a latitude perspective, sun course perspective, astronomical scale as well. So the idea there was indeed to try to enhance or raise awareness of the public by making this multidimensionality and multi-scalability, sort of multi-scale nature of daylight and multidimensionality more accessible through communication channels. And so this led to projects by the DLA like Daylight Matters, like discussions, debates, workshops, and also sort of a representation, a literal illustration of the journey of light starting with the sun and then going down in scale, like to the smaller and smaller, and then try to represent what this means in terms of research questions, activities, sort of questions asked, and then connect this to an expert network. So at any scale, for any aspect, kind of who in the big network of the DLA kind of works on that, and you can reach out to them, and there is a tiny bio and some contact info. So it's also a facilitator for contacts and to know more.
Right on. Okay. Let's talk about one other project, the Daylight and Green Cities project. Mm-hmm. And I know I'm moving really fast, but there's just so many things I want to at least touch the surface on. The Daylight and Green Cities project. Explain what that project's about and what you're trying to achieve there.
Yeah, so first disclaimer, I was not involved directly in this project. I just know about it, but I know that it's a project about the relationships between daylight access and urban planning practices. So a very simple example is increased densification trends in cities means narrow streets, high buildings, open spaces that are the pockets of access to daylight, but it does raise a lot of question about what this means in terms of light access, daylight access. And so Carlo Wolf and others have been working on that. And now we are going to and have published it. And now we are going to a next step whose shaping I actually was more involved in through that societal topics group that I was mentioning before, strategic group, which the question here is to try to work kind of on the tension between daylight and urban density, but with a global perspective. And I was, in fact, in charge of maybe developing that topic a little more. And so the idea is to try to differentiate what is objective, like latitude, photoperiod, so length of day, depending on where you are on Earth. What is also objective, but very much more local, like culture, habits, traditions, and therefore what you expect from light in a given place, and then trying to look for what could be maybe metrics that would be relevant to urban planning, but could speak about the diversity by latitude and by cultural environments. So that's possible next step. Yeah.
About a year ago, it was about a year ago, I know Lisa Heshong was involved, and it wasn't so much a paper as kind of like an op-ed piece where she was promoting the idea of daylight as a human right. And that kind of ties in a little bit with the Daylight in Green Cities project. Is there any kind of movement at all? Like you'd be tied into that. Do you see that gaining traction, the idea of daylight as a human right?
Yes, I would say there is an upwards trend in that thinking or these questions. So the right to light has existed a long time ago. And I would say that now that chronobiology especially has made a lot of progress since the discovery of the IPRGCs, where Russell Foster, the laureate of the Daylight Award, was key in making this discovery actually solid and accepted as such. Now that we know more and has had 25 years or so to work on the topic with more agenda and agency, this question is more and more there, that we have actually distanced ourselves from the conditions under which we evolved. We evolved outdoors with the photoperiod as being the driver of our own time. And once we moved indoors with electric lighting, we are now at least in urban environments, in chronically light deprived environments during the day and probably overlit environments in the evening. So we delay our kind of biological day through these means. Nights are not dark enough. There is light pollution, and therefore the contrast between day and night has been reduced. So all of these have health implications and well-being implications. And this movement about the right to light is going back to the roots of, we are starting to lose something that is essential to our lives. And as a matter of fact, I have co-developed with a design firm in Paris called Vraiment Vraiment, an art installation that is currently on show in a museum here in Lausanne that is called Droit au jour, the right to light. And that is literally a kind of a fiction, an administrative fiction of a utopian administrative office that would be there to ensure you have the right to light, the right to daylight or to the day, and go through analyzing your chronotype, analyzing your sensitivity, seasonal sensitivity to light, giving you tips about good habits like a good light hygiene, and kind of formalizes of course in a fiction, what would be a society that would make this a legal right, back to a legal right. So it's not something we necessarily want to happen, of course, but it's mostly to raise awareness that this is something we should cherish and we just should care for.
Yeah, fantastic. Well, I mean, imagine a dense city and you're living near the bottom of one of these incredible skyscrapers you may never see. You'd have to leave town literally to have access to sunlight, or, just get on the elevator and get to one of the higher levels. It really is. We're heading to an interesting place. All right. Again, there's more things I want to cover. You just mentioned art and science together. I know you do some work bridging the gap between art and science. Can you talk to me about that a little bit? Tell us why you think that's important and what else are you doing to move us in that direction?
Yeah, I think it is very important to diversify the ways in which we try to convey scientific discovery or a love for science more broadly with other formats than publications, books, lectures, talks, seminars, podcasts. These are all great ways to disseminate and to raise awareness, but we can also expand to more personal, emotional things that engage you as a human being in a way that you don't fully control. And this is what the magic that happens with the lens of art is, that you don't explain, you don't describe, you cannot expect or control what you have prepared to be seen or experienced is going to be received. You deliberately let the visitor, the person that experiences it, a bit in charge of what they want to get out of it. but it has an effectiveness that I was surprised myself. So, for example, I co-curated with 3 other wonderful curators from different disciplines an exhibition called Lighten Up on Biology and Time. So this is precisely the theme that we were mentioning at the beginning. And it was about raising awareness to this scientific field, but through the lens of art. So there were many artists in the world that work on this subject in their very peculiar, unexpected ways. And when people visited that exhibition, whose first edition was at the EPFL pavilions and now is in winter tour, and now will go to the MIT Museum in a few months. So it's touring and has the success I think it deserves. The idea is, well, what I observed rather is that people would sometimes come to me and say, oh, wow, but so light is really important and I'm going to change my behavior and so on. And I think many of them may not have had that reaction if they had listened to, let's say, a lecture of mine, even though I try to be engaging and explain things properly, but it's not the same effect because they took the time they wanted to do what they wanted and how they wanted to receive. And then it touched them and they were touched enough to want to do something on their own will, not because they were told, but because they decided. I think this is a very strong, effective way to speak about science and to engage with people on a different level.
Love it. Yeah, I love that. That's brilliant. I have to do something controversial before I let you go. We got to stir the pot just a tiny little bit. LED lights, they've a bit of a miracle in terms of energy reduction, but we know that LED lights are not full spectrum. Some of the gain in reducing watts per lumen comes as a result of pulling out a lot of the reds and that sort of thing. What is your understanding and what's your feeling of the shortcomings of humans operating under only partial spectrum LED light these days?
So I think it will take a long time to be able to know, really, and to have enough observations and data to really isolate the effect of the spectrum of the light we are exposed to, because we are also exposed to daylight. We have different types of light we're exposed. So it is hard to isolate. This is typical of a field study, like a worldwide field study. So this will take time to really accumulate evidence. What for me makes sense is that our eyes, our brain, our physiology has evolved under full spectrum, continuous light that has a rhythm of day and night. And so this has been shown, or our responses to light have been shown to be sensitive to having enough intensity, the right timing, and the right spectrum, with an eye morphology that has evolved with the full spectrum in mind. Whether it can cope with a non-full spectrum, like with troughs, like missing or some wavelengths that are underrepresented and some wavelengths that are overrepresented, is an open question. Our eye would maybe have evolved slightly differently had it had these years and hundreds of years to evolve under a different type of light. So I guess, without being an anthropologist, without having the knowledge, it makes sense to say that it's a risk. It's a risk because the eye has not adapted. Other than that, we can also say that we have evolved under light levels outside that are very much higher than indoors. And therefore, we are back to, not only in terms of vision, but also in these physiological aspects, of a chronic lowering of the contrast, because we just cannot have as much light indoors than we have outdoors. This is orders of magnitude different. Even though the brain is very good at making them look like it's the same, it's very different. It's 100 times darker inside than outside, even though you think it's similar. So yeah, these are to be seen. But of course, it's necessary in terms of how we live today. It's a very energy efficient technology, so it's a wonderful technology on that regard, and it helps us function in the society we have decided to create for ourselves, a 24-hour society.
So let's talk about the combination just a little bit. And this is a pure curiosity thing on my part, and maybe bigger than that. So let's say a gymnasium. So a typical gymnasium would have a spec of like 1,000 lux as a floor spec, or let's call it an office, 300 lux. It doesn't matter. And I know this is an oversimplification, but if 50 of the 300 lux is coming from natural light, or some percentage, a third of it is coming from natural light and the rest is artificial. Is that enough for us? Is it, do we have to have all 300 lux coming from natural light, or is some combination of the two adequate to achieve the things that our body needs in order for us to be as healthy as we can be in that
Yeah.
regard?
I think in all honesty, we don't know what this ratio is, if any. Is it close to 100? Is it close to zero? The importance of it being daylight or sort of continuous. Is it the continuity of the spectrum that matters? Or is it mostly the intensity that we should be exposed to at enough moments during the day? Even if we are just in 300 lux of LED induced lighting, is it enough to spend enough time indoors on the outdoors in parallel? These are open question and require a huge amount of data and investigation. So I think, of course, it's very cautious step, but to say the closer we are to the conditions under which evolved, the lower the risk of being wrong. But it's a bit sad to say that the current mindset is how low can you go? How far from the conditions under which we evolved is still okay, good enough to not harm us? It's not a nice thinking to think about how not to harm ourselves. I think it would be nicer if we were just thinking of how to have benefits and benefit us. But I think the question you're asking is about this trade-off, and I think we need more data to talk about it.
Right. Okay. Yeah. All right. I hope there's people working on that one, because I think that's a really interesting one. Like, I've worked on projects where it was just impossible because of, external factors and, design of the building to get in enough light to be able to not use supplemental lighting. And it's not uncommon. It happens. Or if you've got a big floor plate and you're trying to get to the middle of the building, you have to use the supplemental light. And so, what's enough, right?
Yeah.
It would be so good to know what's enough, or approximately what's enough, in order to, maybe even encourage more time in the spaces where there's more of the natural light available.
Yeah, but I think the kind of questions you just raised are easier to address. This is a decision to make between investing in one thing and investing in another. And in those cases, sometimes it's about, let's say it's for an apartment, about investing, or let's say a fancy office, investing in marble bathrooms versus getting access to daylight through a better facade, a different floor plan, a little bit of a loss of maybe a productive space or access to skylights. And when the decision is to have a marble bathroom or marble bathrooms because it's fancier, we have to remember that this is a decision based on cultural expectations, on status that we have invented. These are stories we invent for ourselves, that we are more powerful if we have a marble bathroom, whereas we are sacrificing fundamental human needs, which are physiological and are for us as biological being. And this is when the decision is simple. It's hard for me to give you a number or a ratio of daylight versus electric light. It's easy for me to tell you that it's never a good idea to favor expectations or something related to the show-off aspect of a building when it means we sacrifice the more fundamental needs that we should be aware of. And this is where all this work on raising awareness, I think, is very important.
Short lifespan single-use plastic glazing is not a sustainable solution for daylighting. Solera is the glass-based alternative for the new millennium. Learn more at advancedglazings.com. That is an absolutely brilliant quote, and I appreciate that. All right, we're at the point in the show where I ask my million-dollar question, Marilyne, and I ask this of every guest, and I ask them to answer from whatever perspective they like. What makes a great building?
So I would say it's the seamless integration of performative aspects and architecture. An example of this is a building that responds very much to the sun, like in performance, like bioclimatic, is good when you cannot see that, when you cannot differentiate the two. The fact that it is a coherent architectural piece and that actually works superbly well from a performative standpoint. So I think this is a good building, and a good building is one in which we feel good and we can function well, in which daylight can be key because it answers fundamental human needs rather than expectations, as I just said before. The other question is whether we should build it at all. And then I think the answer, at least in places like Switzerland and Europe in general, where we have a lot of existing buildings stuck and not a big growth of population, is it only makes sense if it is a positive contribution to the world. In other sense, the world is better with it than without, for cultural elements, for other. But other than that, it's not a great building.
I love it. All right. Before we go, exciting announcements, any great news, anything that you'd like to promote? I know you wanted to talk a little bit about your new role with GESDA. Let's make sure we talk about that before you go.
And that could be a good, exciting announcement. It's a very fresh one. It's only dates from 3 weeks ago, literally. So indeed, I have taken over the directorship of the GESDA Foundation. GESDA stands for Geneva Science and Diplomacy Anticipator. This is a foundation whose mission is to try to promote anticipation, an anticipatory mindset. So in other words, it's about preparing ourselves for the deep transformations of the world as we know it, notably due to scientific advances. So it's about preparing us to what these amazing scientific advances in AI, in neurotech, the effects on climate change, all of these, what they will do to the world, and be proactive in kind of challenging the status quo, so to not wake up too late. And this means that we have to work hand in hand with the diplomatic world, the diplomacy world, and the world of politics. And so it's a foundation that really tries to be very much grounded in science and working with thousands of scientists across the world and be relevant on a global scale with all regions, especially those that are maybe underserved, to make sure that we act early and in knowledge of what awaits us. So it's, I think, a very important mission, especially nowadays. And if we want to go back to daylight, it's a fundamental need we will always have. So as a result of evolution. But of course, the agenda of GESDA is much more broad and is really about these big scientific breakthroughs and their meaning and how to be able to act knowing about them.
That is a huge responsibility. I'm glad it's in good hands, Marilyne. Thank you so much for your time today. Thank you for being here. It truly was an honor and a pleasure speaking with you as well.
For me as well. Thank you very much, Joe.
Take care. We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.